Hello and welcome to CES 2023. We are very excited to be here. First, I want to thank the IoT M2M Council for having an amazing set of speaker events lined up across the 3 days. Very happy to be here. My name is David Duncan. I'm a consultant with Strategy of Things. We are a Silicon Valley-based innovation firm using strategy, science, and technology to create smarter, safer, more responsive, and resilient cities and communities. I am here today with Carmen Redondo of KYOCERA AVX to learn a little bit more about the importance of antennas in IoT. With that said, Carmen, can you give a little introduction about yourself and KYOCERA AVX?
Hello everyone. So I'm Carmen Redondo, a Director of Global Marketing of Antennas for KYOCERA AVX. KYOCERA AVX is a manufacturing of advanced electronics. There are many different components, connectors, capacitors, sensors, and among that also antennas, which is what I'm in charge of.
And I must say, Carmen, I stopped by your booth right down here a couple minutes before our interview, and I did see a wide variety of different devices, from smart meters and connected streetlight sensors, all the way to pet finders and wireless headphones. And clearly they all have antennas, so I wanted to ask you, what is the importance of antennas in IoT devices?
Well, all the IoT devices are wireless, right? And without an antenna, you can't have anything wireless, so that's the importance. However, nowadays, I think most of the manufacturers, they focus on selecting the right module, the one with the lower power. However, they don't think of the importance of the antennas. And when you integrate the antenna, if you don't have the right product and the right location, you can really reduce the performance drastically, you know? So that's why it's so important to consider the antenna in the very beginning.
Sure, and I know there's many different factors, whether it's cost or frequency or size, many different factors that go into these devices. So I wanted to ask, what are some of the considerations when implementing embedded antennas?
So when you embed antenna inside a device, I think the most important part is to know the size of the device and where the antenna is going to be, because everything around is affected. For embedded antennas, it's not only the antenna radiating, it's the whole device. So you have a very small device, especially for low frequencies, then it's not going to radiate efficiently. You have it very small. So that's, I would say, is the first consideration to have into account. But it's not the only one, because you also need to consider if this device is going to be implemented close to the human body, because the human body can also have some absorption of the power. So it's not as straightforward as people think, right?
And so do these considerations typically come from the client? They reach out to you saying, hey, we have X product we're looking for and we need an antenna?
Correct. And I think our best partners, I would say, our best customers are considered partners, right? So they come to us in the beginning of the project. They say, Carmen, we have this project. This is the size. This is the technologies we want to implement. Tell us where we should put antennas. So what they do is that they put they book the space for antennas. They kind of make the size we recommend, and then they design the whole, let's say, cosmetics and everything around it, right? However, in the IoT market, we see that there are so many different sizes of companies, and many times they come to us when I will say it's too late, because they already designed the housing, they already designed everything, and say, oh, now we need the antenna. And sometimes it's very, very challenging to be able to implement it there, right?
Now, could you give an example of a company that may have come to you too late, as you described, and how you resolved that situation?
Yes, so let's say like in a tracker, right? They come to us and they say, okay, this is, this device is not, well, I remember one case where they have an off-board antenna, so you can have embedded, you can have it antennas on board, right, or directly on the PCB, or you can have antennas off-board with a cable. And people really think that antenna off-board are easier to implement because it's like a sticker, right? So it's okay, I just connect it and I stick it. So this customer came very angry, saying, oh, the antenna is not working, and what have you gave me? And it's because he placed the antenna on top of the PCB, like a sandwich. So of course he wasn't radiating anything, right? Sure. So we had to help them to design a custom design with a very limited space they have around the housing and the PCB. So it was very, very challenging project, but we finally helped them. And they could have had much better performance if they would have come to us earlier, right?
Hear that?
But,
That's great. So are there any ways you can validate the IoT device and antenna performance? Like you said, they had implemented an antenna and it wasn't working. So what are ways you go about validating this?
So absolutely. So from the antenna side, the first part we do is the passive testing. So which means that we are only checking the antenna part validation. So we are doing testing like return loss, efficiency of the antenna. So for that we have some equipment in our labs. So we have labs all around the world, in San Diego, in France, South Korea, Taiwan, and China. And all of them are fully equipped to be able to do prototyping, to make measurements. We have anechoic chambers, and we are able to validate antenna performance. How is the radiation pattern of the antennas, how is the efficiency, etc. But later on, the next step is to validate the full product, right? And for that, it's not only the antenna, because you also have module which is connected to it. So in our chambers, we are able to measure the TRP and TIS, which is total radiated power and total isotropic sensitivity, which means that these are the values that the operators will really use to validate your product. So we are able to do this testing, and then we can see, okay, look, you can go directly to the operator because your product is ready to function. Mm-hmm.
That's very interesting. Now, are there any other antenna project that you have done that you'd like to highlight, or any very interesting use cases? Like I said, I did see the pet tracker. Mm-hmm. I saw the smart sensor.
Yeah. So there are two types of different antennas we provide. So one of them is a standard. So because we have, as I said, many different types of customers, right? And not everybody has the opportunity to have a custom design for their product. So we have standard products, based on FR4 and metal stamping, flexible PCB, but also we are doing custom designs. And this is the pet tracker that you saw is very interesting because the space is like, I don't know, like a few centimeters of diameter. It's very, very limited space. And what we did is that we put the antenna directly on the plastic, which is a technology called LDS. It's laser direct structuring. And what we do is that there is a special resin that has some metal particles that when we burn it with a laser, you can directly implement the antenna on the plastic. So that helps you to have good performance in very small devices. Mm-hmm.
Well, that sounds like a pretty impressive technology. So, as you saw, the antenna is getting smaller and smaller, embedded in plastic. What are those the limitations, or where are the limitations in this? Is it not the antenna? Is it the actual the device, or?
Yes, it's mostly the device, because everything is radiating, right? So one of the technologies that is coming more and more popular in IoT is the band switching. So the band switching means that when you have a passive antenna and you are not able to cover all the bands that you would like to, we are able to use a switch that is connected to some matching components, and we are able to switch band, so you can optimize for each of the bands instead of having to cover all at the same time. So in KYOCERA AVX, we also design chipsets, and this is one of our products as well, so we can give the full solution to our customers. And then we have partnerships with module makers, for example, with Ublos, Telit, Nordic, and many others, where we are providing these solutions in reference design to make it easier to our customers. So when they go there, they will find the antenna, the chipset, and the full solution working. So they only need to replicate that because we already validate that solution.
That's incredible. So antennas, chipsets, testing, validation. Is there anything else that KYOCERA AVX is involved in?
We also have a lot of online tools. So our mission, and that's one of the reasons why we have joined the IMC Council, is to make it easier to our customers, because we see customers which are going again and again through the same challenges, and we would like to give our lessons learned in advance. So we are trying to increase more and more online tools where they can select, okay, this is the module I'm using, this is the antennas I could use, or for example, we have online an IoT solution optimizer, This is powered by Deutsche Telekom, and it's a very powerful tool. It's a digital twin that now they say, where you can actually validate or design your full device just by the simulation. So it has real data from the module makers, from battery suppliers, and also our antennas. So you are able to put all the data there with actual testing data from us, and at the end they will see how long or how many years your device is going to last in battery life. So that helps you a lot. Instead of doing prototyping and wasting time in testing, you will be able to have some indication of how your product is going to work.
That's incredible, and the point you made about sharing the lessons learned, I think we all can resonate with that. Whether it's antennas or, like I said, we're building smart cities. There's many challenges you face. You have to overcome them, but sharing that information is very powerful. So I wanted to end this. Where could they find this information? You mentioned the lessons learned. Is it on the IMC, or where can they go to learn a little bit more?
Yes, so we have on our webpage, and I will provide IMC one link. We have all our shortcuts to all the tools, and everything is online. And we have even videos to show how the band switching is working, and we have filters to select antennas. So, and more to come this year. So.
Wow. Well, KYOCERA AVX is clearly doing some incredible work. Sounds like they have a lot of resources online, and I'd like to thank you for your time.
Thank you very much for inviting me.
Thank you.
Thank you.